In this video, we will look at example of an RL circuit in which we have voltage source given in Fourier series in phase form representation. So this is the voltage supply for the circuit. It is written in phase form, in which so we have the amplitude and the angle or the phase, and is given for only up to 3 terms only, right? So we can continue this until up to infinity, but let's just look at the solution. Let's just try to solve this for the first 3 terms, right? So the circuit contains two resistor and one inductor. So we need to find the current flowing through 4 ohm resistor and the average power absorbed by the resistor, right? So first of all, we need to convert the circuit into frequency domain or S domain. S domain, right? So basically the 2 ohm resistor will still be 2 ohms. The inductor will become 2s ohms, and then the resistor, the second resistor, is still 4 ohms, and this is the Vs, right? Okay, so next is since we want to find the current here, what we can do is we can find the voltage across here, and divide with the resistor to get the current. Okay, so to get the voltage across these two components in parallel, we have to determine the total impedance for these two parallel components, right? Z to S in parallel with 4 is basically 2S times 4, 2S plus 4, so we get 8S over 2S plus 4, and then we can reduce this the value to S plus 2. Right, this is for the impedance, total impedance for these two parallel components. So then we can determine the voltage across this impedance using voltage divider, right? So V 2S4 is 4S S plus 2, 4S S plus 2 plus 2, and then the voltage, which is at the moment, let's just write this, assume it's Vs, right? Okay, so let's try to solve this first. For S plus 2, for S plus 2S plus 4 is S plus 2. We can remove this, right? So that we get 4S 6S plus 4Vs, right? And then we can further reduce it to 2S 2s plus 2. Alright, so now we can start to determine the Vs. So of course, Vs is the voltage supply, which is given in Fourier series, right? Given in Fourier series. So we have to solve this one by one. We have to solve this voltage for V1, V3 and V5. So this is the original equation is Vn cos n omega naught t plus the angle. So this is the voltage for n, which is V1, and this is n, which is 1 here, and omega naught is 5. Alright, and the angle is 51.49. So let's solve for V1. Alright, this is V1. Next is V3. Okay, and finally V5. Alright, so for n equals 1, V1 is 0.4981 with angle 51.49. Right, 0.4981 with angle negative 51.49. That's the voltage. So if this is the voltage for V1, then we can determine the voltage across the two parallel components, which is 2s 3s plus 2, 0.4981 with angle negative 51.49. Okay, so now we have to solve for s. So s is basically j omega n, which is omega naught n, which is, in this case, omega naught is pi and n is 1. So omega naught comes from here, which is pi, right? Okay, so we can finally solve this circuit, or solve for the voltage. J pi plus 2, 0.4981, 51.49. Alright, so basically here you can get the voltage for which is 0.3248 with angle negative 39.51 degree, right? That's the voltage for n equals 1. Next is for n equals 3. Okay, there is no n equals 2 because n equals 2 is 0. So the second one, the second term is n equals 3. So same thing, this same process. V, voltage across the inductor, which is also the same voltage across resistor, right? So 2, now instead of j pi, it is now j 3 pi, right? Because it is n is equals 3. So j 3 pi j 3 pi plus 2, and then the voltage, which is 0.2051 with angle 75/19. Right. So basically the answer is 0.1364, angle negative 71.14. Right. So that's the second term, or for voltage for voltage n equals 3. The next is for n equals 5. So same process, right? j 5 pi now, s equals j 5 pi. So you can get the voltage is 78.53. Right. So that is just the voltage. That is just for the voltage. Alright. So now we can calculate the current through R equals 4 ohms. So basically R equals V over Z, right? So for n equals 1, I want is basically use the voltage for n equals 1. Right, that is 0.3248 with angle negative 39.51 degree. That's right. So it's 0.0812 with angle negative 39.51. Right. So same process for n equals 3. I3 is 0.0341 with angle negative 71.14, and then for n equals 5, I5 is 0.0209, angle 78.53 m. Right. So basically it's V over Z. Right. Impedance of the current through the resistor. Right. So this is 4 ohms. So this is V1, V3, and V5, which we have calculated earlier here. Right. So just change the value, but the impedance is still the same, 4 ohms. That is because we want to calculate the current flowing through this resistor. So this is the value of the current for each component. Sorry, for each for n equals to 1, n equals to 3, n equals 5. So the final answer for the current is basically in Fourier series, right? It's basically 0.0812 cos pi t minus 39.51 plus 0.0341 cos 3 pi t minus 71.14, and then plus 0.0209 cos 5 pi t minus 78.53, and of course, so this comes from here, 0.0812 goes here, negative 39.51 goes here, same thing for n equals 3, 0.0341, and so on. Alright, now is to determine the average power. Okay. Average power absorbed by the resistor. Okay, 4 ohms resistor. So basically the equation VDC IDC, right? DC component of the Fourier series, in which we do not have the DC component for this Fourier series, for this supply, for this voltage. There's no DC component, so we can just remove that. But the equation is basically summation of V and IN. So this is the AC component divided by 2, and then cos, this is the angle for the voltage minus angle for the current, right? So this is the equation for the P average. So this is this DC component, this is the AC component, so we have to calculate for n equals 1 until infinity. So in this case we have n1, 3, and 5. Right, so basically P average, okay, so 0 for DC component, and then the voltage, the current, and the angle, right? So voltage is 0.3248, that is the voltage. The current is 0.0812 divided by 2, and then cos the angle, right? So the angle is 3951 and also 3951 for both the voltage and the current, right? 3951, so meaning that this is 0, right? So continue for n equals 3 and continue for n equals 3 and 5, 0.1364, 0.0341 divided by 2, and then same thing, cos 0, 0.0837, 0.0209 divided by 2, cos 0, and then so finally, so all this value is 0.0164 watt, right? So there's the reason why the angle is 0, because this basically represent the power factor, right? Power factor. So because of the circuit or the the load that we are calculating is a resistor, completely resistor. So the cos theta is 1. Sorry, cos theta, yes, cos theta is equals to 1. It's because cos 0, right? Cos 0, so it is 1, right?